In today's episode of How to Solve Exam Riddles, we will discuss 3 examples of very basic organic reactions. So, the first example, we have a chloroalkane, and this is treated with sodium ethanolate in ethanol at reflux temperature. So, sodium ethanolate might either function as a nucleophile or as a base. Let us imagine it reacts as a base first of all, then, here it would be at this methyl group deprotonated and HCl could be eliminated. So, one way to react certainly is to eliminate HCl, and then as a product you would obtain this olefin. How about the reaction as a nucleophile? Well, nucleophilic substitution can either take place by an SN1 or an SN2 process. SN2 process here means the nucleophile will approach while the leaving group will leave the molecule. However, since here this is a so-called neopentyl position, alpha to that tertiary butyl group, then the tertiary butyl group blocks the trajectory out of steric reasons for the approaching ethanolate nucleophile. So in such a situation, nucleophilic substitution by an SN2 process just does not work. What about an SN1 process? For an SN1 process, we have a protic solvent, we have higher temperature. It is possible that chloride leaves the molecule, setting free a carbocation ion, a secondary carbocation ion, as a reactive intermediate. But in this case, the sodium ethanolate won't have enough time to approach as a nucleophile. A very fast reaction will take place, Wagner-Mehrwein rearrangement, forming this tertiary carbocation, and then it will certainly be deprotonated by the sodium ethanolate, and as the final product preferred at these higher temperature, we will obtain this tetramethyl substituted ethene. So, next reaction. An aromatic system with a side chain, chloride as reagent, and photochemically irradiated. In this case, clearly a photochemical radical chain process will take place. Chlorine radicals will be formed, first abstracting a hydrogen, a radicalic hydrogen, in benzylic position, because then a benzyl radical, which is mesomerically stabilized, will be formed, and the second chloride will also react here. So benzyl radical will react with chlorine. One chloride is attached. Another chloride radical is set free, will attack again abstract a hydrogen, radicalic hydrogen, and this is the radicalic chain reaction. So this product plus HCl is formed in this case. Third reaction for today, we have benzoic acid ethyl ester and aqueous hydrochloric acid. And we will heat it up at elevated temperatures. Well, what will happen? First question we should ask, well, if we have HCl aqueous, from what is the predominating molecule? Here in this case, of course, water. So essentially it is water and a protic acid heating up with an ester. This is an ester hydrolysis catalyzed by an ester, by an acid. So the result will certainly be formation simply of benzoic acid plus ethanol. The HCl is just the acidic catalyst. Thanks for listening.